Okay. That's kind of fun. Disconnected from. Finally, we meet, and then I'm disconnected. Hi, I'm Peter. I'm going to give a talk. Yeah, no, thanks, Seki, for setting this up, and we're going to improvise. I'm very happy to meet with you all. As we were discussing, it feels like the first time we can meet in person and build up a community. For me, that really is the case. Yeah, let me. I don't have the time, so Seki, can you warn me 18 minutes? Yeah, okay, because it would be nice to have also discussions. Let's see. Yeah, okay. Responsible design for quantum technologies. So that's the topic of this session, of the two papers. And as a philosopher, I immediately start looking at the assumptions in this topic. So, okay, what am I supposed to talk about? And in a sense, I liked it to be also a bit insecure about the topic because it's not so clear yet what we should do. And then I mean the social scientists. I know you're a physicist, but what with we, I mean in this paper constantly philosophers, social scientists who look at quantum technologies and their development and try to participate in that. So the other, not we, is the physicists. So sorry about it. Okay, so if you take that distinction, you can easily say, okay, whose responsibility are we talking about? The default position is, okay, we have a technology, it should be developed responsible by the developers and the designers and the researchers, and we can help. So the responsibility is about the researchers. More interesting, actually, is how about our responsibility? We step into this field. Should we act responsibly? So when I teach at my university, I'll tell a little bit about myself in a minute. I tell to the engineers, look, don't hide behind the people who assign you. You have to take responsibility yourself, because you might be liable later. And you have an active knowledge of to proactively change technology because you know the others don't. Well, let's reflect that back on ourselves. What is our responsibility? So that's the question I will take up. I'll say a little bit about that, and then I hope that we have a nice discussion about it. I really also want to tell that it's not leading to lots of new things. If you read the paper which was on the screen by Caroline ten Holter, you'll see the same things. But I want to frame it explicitly in this audience as our responsibility. We should do some things because we are responsible. So what I want to do is look at quantum technologies. Say something about how researchers and we respond to the specifics of quantum technologies, and then focus on our responsibility. Should we do additional things in addition to offering our services? It will be very general, so I flatly ignore quantum sensors and the details of discussions about Shor's algorithm or QPD. It comes back, but this is kind of a general talk. Okay, a little bit about myself. I'm Pieter Vermaas, working at TU Delft. I'm part of one of these enormous investments in quantum technology. So 600 million in Holland on developing quantum technologies. The bulk of that investment is, of course, on research and development of quantum technologies and labs. And so that's the white core in the middle of that organogram, and the cheese parts. So 3 labs, lots of research, but the people who designed this program understood our messages that you cannot just focus on research. So there are layers around it which make the connection with society. First layer is industry. How do you get all these findings to industry? Action line 2, that is. Third line is how can we find the people who can help that development? So human capital, education, and competing with the rest of the world and get talent to Holland. And then I am the 4th action line, this, the outer ring, the center of content and society. And what it does is offering services to, within this big program, analyzing, exploring the ethical, legal, social, societal issues of quantum technology applications. And it comes in a kind of levels of complexity. We offer simple tools eventually, where do-it-yourself scans by industry. I have this application. What will it lead to? To actual workshops in these kinds of environments, where companies can explore the impacts of their applications with us. Important, also later for the talk, is we're not just responding to questions. We also say, okay, we have our responsibility ourselves, so we're going to start mission-driven innovation. So if we have a goal, we'll pose the question, how should quantum technology change in order to realize that goal? Finally, we have a decent amount of research, and Luca Passati is part of that research. Added to it, more academic research, ethical, legal, societal. I'm the ethics person, and the others are Joris van Hoboken, Julia Kramer, maybe the names sound familiar. Okay, that's me. Now let's go to quantum technologies. What is kind of interesting from these technologies, the 4 characteristics I want to focus on, is that it's completely enigmatic. It has an enigmatic basis. It's really strange that industry already jumped on it 5 years or 10 years ago. They typically only jump on developments if there's a perspective of an profit, 5 or 10 years. But here that's kind of different. Subjected to geopolitics, increasingly, and important, it's so generally useful that it's actually not clear how it is useful. So it's a technology which is kind of out there without a specific problem, ignoring shore and stuff like that. Okay, I'll go through these characteristics to analyze what we are already doing, and to later be able to say, okay, what should we add? The fun thing is that the researchers use all these characteristics to get more funding. It's also hilarious. So they typically start saying, when they present for a general audience, say, wow, you don't understand quantum, and therefore it's really enough. So give us the money. So that seems to be a kind of argument which they run. And what we do with that, say, yeah, okay, that's not a good way of approaching responsible research innovation. Let's also inform and involve society. But of course, there is something going on with quantum mechanics, the basis of quantum technology. So we should definitely also look into these features, like it's irreducible, stochastic, probabilistic. Okay, what does that mean for accountability when you run a quantum algorithm, for instance? Okay, nice, good topics, all based on this. The second is early adoption by industry. Again, the researcher says, yeah, especially in Europe, give us enormous amount of money, otherwise we're going to lose. Because these big tech companies monopolize the technology, and we actually want to have Quantum Valley this time here in Europe. We're not clear whether it's in Holland or France. I think it's Holland, but or maybe Germany, I don't know. But that's the kind of argument which is run. And we, as a group, respond to that. So, yeah, be careful, these big companies. Is that so nice? My university has a Microsoft site on its campus. The doors are closed of that site. Do we like it? So we run the argument of, okay, it should remain accessible. So be careful with that. Geopolitics emerged. Increasingly, okay, I don't have to say what the researchers say, but they need more money, and we talk about safeguarding openness. So what we were talking about, this model of open science, we need it. Actually, we need it. So we also a kind of utilitarian argument. We need open science to actually build the quantum computer. So let's keep that, and in the process give others access to participate in this research. Finally, and I think here the things get sticky. So this general utility. Again, the researchers say, well, so since it's so generally applicable, quantum computing, internet, whatever, they come up with this enormous rhetorics, sweeping statements. It will rapidly change everything. A game changer. By the way, will solve any societal challenge you have. I asked 5 years ago, okay, how do you want to do it? Let's do climate. Say, yeah, it's artificial fertilizer. That's the solution. The next question was, okay, what's the link? And no one knew at that moment. Do you know what the link is? Yeah, that's okay. That's a guy in Germany.
But you mean link from climate change to fertilizers, or from quantum computers to fertilizers?
Just filling in the gaps.
Okay, so you could use the quantum computer to optimize maybe the production of fertilizers, and Haber-Bosch is one of the ways how to bind nitrogen into ammoniac, and that's taking a lot of energy. So you could reduce at least part of that amount of energy from our general waste. From what we need to invest to take fertilizer.
Yeah. No, partly, because if you would increase the efficiency of this thing, it would not really save the climate. But there's a claim that it takes about 1 or 2% of the full energy. Yeah. So eventually they could make the link, but it was really a thin line. Okay, so this between these sweeping statements and actual what's out there. And if you push them, they also say, well, yeah, by the way, we're not really certain if we can build a quantum computer, because 1 million qubits, quantum repeaters, it's difficult. So they're kind of ambivalent. We criticize the hype, say, yeah, be careful, and we try to bring in some meaningfulness, saying, okay, let's focus on some domains first, and then also then kind of more amorphous statements of let's focus on the sustainable development goals. It's good, but it's again quite generic. Well, what that means for me is that quantum technologies is a really general technology boosted by political and economic factors, but clear technological aims that computer, those sensors, those internet, we know what they're after, but society is kind of up to grabs. It creates a kind of vacuum where you can say more or less anything. It's uncrystallized. And what you see is also, again, really divergent statements. Quantum should be used for the benefit of whole humanity. And at the same time, quantum should be used to support our security, our independence, sovereignty. And in that domain of options, what could happen is that what certainly to some extent happens is that we, as a community of social scholars, just respond. There's so many claims out there. Yeah, we can criticize, we can explore, we can develop. That's good, but I think we should do more. Because if we're just responsive, the agenda is set by whomever shouts hardest. Whereas I think we, on basis of our knowledge, know already what could come. So we can take responsibility, and that would mean act more proactively rather than responding, and more targeted. I brought a couple of proposals, but actually it's that what I also would like to discuss with you. Yeah, inform society. Sure, of course, it's good. No one can be against it. But it's also, again, quite generic. Shouldn't we be much more targeted and say we want to draw in some groups explicitly into this development? We know what's happening, or what could happen. We can explore that. Take these stakeholders in and inform them specifically. So if societal challenges should be addressed by quantum technologies, well, let's go to the stakeholders who are related to that, from poverty to whatever, inform them and draw them and bring them to the centers of quantum technology. I was very happy when Astrid Buttinger said, okay, we want to explore what the social scientists themselves can do with quantum technology. So not analyze it, but just use it as a means. Great, yeah, sure. Yeah? So we know that other groups might be able to use it. And a topic which Christopher and I like is, okay, we also know that quantum has a different perspective, meaning in society since quantum technology. So let's focus, let's look at them. We don't hear them yet. So what's happening there? Okay, I have to rush. Geopolitics. Sure, let's have that argument for open science, but also take responsibility there. We can assume that if there's a development in blocks, who will start that dialogue? Who will maintain the dialogue, the global dialogue? Well, if you assume that, let's say that we enter into a phase where researchers are either European, US, or China, and they don't collaborate anymore, can't collaborate anymore, well, we can still collaborate. I can reach out to my Chinese colleagues to talk about what's happening, how we could respond to that. Also, the nations outside of the blocks, they seem to be absent in this discussion on geopolitics. Finally, target specific goals. That's what my center does with mission-driven innovation. So be much more specific on what kind of goals we can realize, and then also organize the events to do that. Political depolarization. And we talk about internet causing polarization in society. Well, if we build a new internet, let's focus on that one. I don't know how to address it, but it's a good question. Okay, wrapping up. Sure, we should bring our technology, our tools to the field. We should do responsible innovation, design for values, technology, constructive technology assessment, the whole spectrum. And also, when we have applications, it makes sense to do that. But we should not stick with that. I spoke with legal persons, etc. There's already so much work on the claims which are out there. We don't take up new ones. Okay, I think that's not the responsible approach. We should take this proactive approach and also shape the development of quantum technologies with our knowledge. Well, that was my claim. I'm curious what you think about it. Any comments? Sorry, in the front.
Yeah, I've many comments. I really like your talk, and it resonates with some of the things that I was going to say or in the panels.
No, that's good. Develop it.
Yeah, no, it's fine. It's good. I think there are a couple of things which I agree with almost everything you say here, and I'm really on board with your program of being proactive. And I think just wearing my old constructive technology assessment hat and wearing my new mission-oriented innovation hat, I see some of the challenges of social sciences engaging with engineers and physicists in anticipating on the co-evolution of their technology with society, technocentric perspectives and frames, and now thinking, well, okay, bringing in societal goals requires thinking about societal systems in which quantum will be embedding. How do you choose those playgrounds to explore the future possibilities of quantum technology? And it links a little bit to the responsibility that we have in terms of shaping how we think about which futures.
Yeah. Fully agree. So the integration, what maybe our term would be socio-technical systems. How do you integrate these technologies into? It's a big challenge. What I know from physicists, being myself one originally, is saying if you say, well, there's a problem, they wake up rather than shy away. Say, yes. Okay, oh, there's a problem. Okay, well, give it to me because I want to show that I can solve problems. So if I look at how they proceed with quantum internet in this European initiative, I said, well, they're not. They can adopt this systems approach. But certainly, yeah, I agree with that. There's
a second question I've got many, we talk later about that. It's about the hype. You mentioned about the hype and being critical about the hype and interrogating the hype. One of the things that we find in France on a totally different topic, mission-oriented research for alternatives to chemical pesticides. So the chemists are working on alternatives and other people alternatives. Funding agencies trying to fund breakthrough science, but it's mission-oriented, find it very difficult to create programs that, how can I put it? They find it very difficult to support funding natural scientists to think about missions. How do you do that? It requires a different kind of support system. And so in France, they're experimenting with new ways of thinking about the future. These are funding programs, working with researchers and program managers to think, well, okay, what are the minimum requirements to sensitize natural scientists to these things so they can just do a little bit better? I think this is a key thing for us because we can interrogate and explore it, but we live in a regime of technoscientific promising where people are more or less forced to exaggerate to get resources, but also then with the mission-oriented side, think, well, how do we contribute as natural science? How do we trace our contribution or anticipate how we may steer our research to contribute? So it's not really a question, I'm sharing a thought. Because for us, in my lab, we're wrestling with these issues. What is the right way Well, there is, I mean, there's no right way, but what sort of experimentation should we be doing as social scientists with natural scientists in this world? Not just with researchers, but with the whole layer up to policy, with funding programs, things like this. Do you have any comments on that? Or?
Yeah, but so I don't know about the social science realm, but I know in the philosophy realm, after Langdon Winners, it's a famous name. So do artifacts have politics? Okay, he analyzed how technology affects political constitutions. And one of the responses to that, it's very classical, so it's them and they. So yeah, these stupid researchers, they don't know about missions, whereas we can criticize that and put a knife into it. But after that, a group said, okay, well, if we can predict it so well, analyze it so well, why don't we co-design it? So you saw in ethics, things like value-sensitive design. In my university, design for values. Philip Brey, you might know, ethics by design. So all of a sudden, we as a group become not, let's say, the journalist critical party looking at the scientists, but co-partners shaping it. I think that there's a way forward, but it brings responsibility. Christopher, you're timekeeping, say.
Yeah, I am, and we are almost at time. Last 30 seconds.
30 seconds, Christopher.
I applaud you for 30 seconds.
Okay.
I think there's 2 questions online. Should we put them in the chat? Or?
Yeah, sorry. So maybe we can have 2 minutes of questions. Sure. We can hear you now.
Okay, yeah, I just wanted to, I think Marcus also has a question, but
Perfect.
so maybe since I'm speaking, I have 2 questions and you can decide whether you want to answer them now or later. So thanks a lot, Peter. And maybe before I ask, I should say I'm a philosopher working at one of those big corporations now. So when you hear me, I think I'm speaking kind of partially out of both roles and both experiences, so to say. I wanted to ask about the first assumption you challenged. So kind of the assumption on that people are putting forward on quantum is different. And I wonder, don't we, in order to work on responsible quantum technologies, don't we also need to a certain extent, uphold that quantum is different assumption in order to justify the efforts we are doing? The reason I'm asking that is that a tendency I'm observing is that a lot of people, especially when it comes to quantum ethics, they just want to say, well, why do you bother? It's an accelerator for AI. So why don't you just apply the AI ethics principles we've been busily developing the last 10 years or so, and your problem is solved? And you can hear from my question that I don't think that's the right approach. So I think we need to a certain extent, we need to uphold a quantum is different assumptions. So I was wondering how you see that, and to what extent you think also whether more specifically you've kind of delved into where the different normative challenges are that are different to, say, AI. Whether there are any, whether we need to make that argument. So that would be my first question. And then my second, which I think ties into what the speaker before me was kind of asking towards the end, is I find it interesting that, especially on the slide is that still up, you're kind of almost calling for philosophers to be very active. And one of the reasons I left academia, so to say, is that I was somewhat, as a political philosopher, frustrated with the litter action or that would follow from the papers we'd be writing. And so I'm wondering whether this is now consciously calling for, more activist philosophers. Since, maintaining the global dialogue, you could argue that should be an international organization using quantum for good. There's this, like, in institutes like the Jester and so on doing that. So I wanted to kind of get clarity on whether you also think there should be more of a activist philosopher.
No, please come back to philosophy. We're getting active, and the pay is much better, I'm sure. Yeah, no, there's an active move, but it should turn, and it might be stronger. Let me pick up on the first question, also in light of time. So it consists of two parts. One, are there specific normative issues around quantum technology since by their quantum nature? I find that a really academic question. Which is fun, eh? So we philosophers do academic questions, but I think it's not addressing the societal impact of quantum technologies. And so I don't care if the impact of quantum technologies is similar as other technologies. I think it's our responsibility to help guiding that impact in the right way. If there's an additional paper on what is specific of quantum as compared to other technologies, yeah, fun, good fun, but it's not the main bulk, I would say. What was your first questions? Oh yeah, the specificity of. Should we take it into account? Yes, I think what I saw in the beginning, so that was also my first paper in the field, was that it was also this enigmatic basis was used to scare away other stakeholders in the debate. So any outreach or stakeholder meeting started with 15 minutes of physicists talking, explaining what qubits were and entanglement, and the effect was okay. The rest thought, okay, well, okay, well, we don't understand it. So when is lunch? And that's not right. So I think we should do an effort to make it intelligible, and so I would support that. So. Yeah, let's stick to the specificity of quantum technologies for that reason.
And maybe very quickly, Marcus, if you want to ask your question, or later you can just send it and I can ask Peter and write you back.
Yeah, maybe it's a very simple question, maybe also related to what was going on right now about specificity. So you have the RI and LC, and this is applied to synthetic biology, nanotechnology, all kinds of technologies. It's very generic, kind of horizontal approach. So the question here is, where do we leave the zeitgeist or the usual approach to any kind of technology in a general sense and come to the specifics of quantum technology? And what would that be?
Yeah. Now the first. What comes to mind, it's not a complete answer, is that I don't believe that quantum technologies is presented in the same way as these other technologies. If I remember nanotechnology, we were discussing that. It came with visions of, okay, we're going to put submarines into your veins to make you to heal. And by the way, uploading brains and minds and actually immortality are also quite close by. So the nanotechnology was presented with maybe absurd, if you look back, but a clear vision. This is what we're going to do. And with quantum, I don't see that claims. It's much more amorphic, saying, yeah, we're going to solve everything which we have. We're going to solve it because we can calculate more. So that's a specific, and that's in part the reason why I say we should be more responsible to actually add that vision or add possibilities. I'll leave it to
yeah. Thank you.